Good morning, students. Today I am going to take 10th standard lesson 5 acoustics. Already we have completed our portion, so the continuation I am going to take. Okay, all of you have learned that portion. I think whatever I have taught on that previous class, you have understood, I think. So you have learned, I think. So today what we are going to learn now, students, reflection of sound. So that day we have learned reflection of sound. What is reflection of sound? The bouncing back of waves from the interface of one medium to another medium, isn't it? So today you see, children, if you are talking inside a room or near a mountain or a big building, we are hearing our own sound again. Okay. So how that sound again repeated back, our own sound, how it is repeated back, that we are going to learn. Okay, that is called as echo. Okay. So what we are talking, that again we are hearing, that is called as echo. Okay. So in this acoustics, okay, here we are, what is acoustics? Acoustic is the branch of physics. Here we are learning, this is the study about the transmission, reception and control and effects of sound. Okay, that only acoustics. Okay, so today in this acoustics we are going to learn about echoes. Okay, what are echoes? Okay, that echo is the sound, reflection of sound due to the reproduction of sound, reproduction of sound due to reflection from some rigid surfaces such as walls, like that some mountains, buildings, ceilings, etc. Okay, children. So what are echoes? So the definition you have to know. Whatever I am teaching, you have to take the rough note and write there. Okay, the definition. I am writing the definition for echoes in the blackboard. What is echo? An echo is the sound reproduced due to this echo is because of the reflection of sound only, actually. Okay, due to the reflection of sound of this original sound from various rigid surfaces such as walls, ceilings and surfaces of mountains, etc. Okay, this is the definition of echo. What is echo? An echo is the sound reproduced. Due to sound is reproducing. What sound we are hearing or we are producing, that is reproducing due to the reflection of original sound. Original sound is reproducing because of the reflection. Okay, from various rigid surfaces. It is reflecting from various rigid surfaces such as walls, ceilings and surfaces of mountains, etc. Okay, children. So, if you are clapping or shouting near a reflecting surface, that means near a building or in a big hall or near a mountain, we are hearing our own sound after a small interval of time, we are hearing our own sound again. Okay, that is echo. Okay, if we are talking in inside a small room, we cannot hear the echo. What is the reason for it? The small room does not satisfy the condition for this echo. Okay, so for producing some echo, we have some conditions. Okay, that if we are talking or we are shouting or clapping at a place, the conditions are there to produce echo. That if the conditions are satisfied, we can hear echo. Okay, so what are the conditions? Okay, conditions necessary for hearing and echo. Conditions necessary for there are two conditions are there. Okay, first, if we are producing one sound, if we are hearing one sound, the persistence of that sound in our ear is 0.1 second. Okay, that sound will persist for 0.1 second in our ear. Okay, so at that time, if we are hearing another sound, this means that we can hear the sound waves clearly in this 0.1 second. If you are hearing another sound, after this 0.1 second, we can hear that clearly. So the time between two sounds 0.1 second. Okay, then only we can hear the two sounds clearly. That means if you are producing a sound, after that after this first original sound, after 0.1 second later, we are hearing the echo. We can hear the echo clearly. Okay, that's the condition. Okay, students. Next, the minimum time gap between the original sound and the echo is 0.1 second. Okay, that is the first condition. Then the second condition, children, the above thing is the distance between the surface of the. Then another second condition is the distance between the source of sound to the surface of reflection. Okay, that distance is the second factor. So here we want to find the velocity of our sound. So velocity of sound, learning time, we know distance traveled by time taken. The distance traveled by time taken. Okay, so for the velocity of sound, you see, so V is equal to the distance traveled. If you are producing on sound, it is going from here and touching the ball or rigid surface and coming back. Okay, so the distance traveled 2D. Okay, 2D, same thing, going distance and coming distance. Okay, together 2D divided by time taken T. Okay, so the distance between, how much distance we need to get an echo, to hear an echo. Okay, so D is equal to, we have to cross multiply this B, T have to come here, so B is equal to BT divided by 2. Okay, so we know the time, the persistence of time, the minimum sound. Okay, so that is T is equal to 0.1 second. Okay, so this is the time gap between two sounds. Okay, T is equal to 0.1. So that we have to substitute here. When substituting, D is equal to V into 0.1 divided by 2. Okay, so we will get 0.1 divided by 2, we will get D is equal to, we have to multiply numerator and 10, numerator and denominator. So we will get D1 divided by 2. So here 0.1 into 10. So into 10. So what will we get? D into 1 divided by 20. So this one will be. Okay. So the distance need to hear an echo is equal to the 1 by 20th part of the velocity of sound in air. Okay, velocity of sound in air. So the velocity of sound in air we can take as if the velocity of sound is v is equal to 344 ms per minus 1 in air, velocity of sound in air. Okay, we will get here v is equal to 344 by 20. If you are taking 17.2 meter, we will get 17.2 meter. Okay, so the minimum distance required to hear an echo is 17.2 meter. Okay, so the minimum sound required to hear an echo is 17.2 meter. Okay, children, now let us understand these are the two conditions. First condition is the persistence of sound. Okay, is 0.1 second. The time gap between minimum time gap between two sounds to hear clearly is 0.1 second. The minimum distance between two surfaces to hear the sound is 17.2 meter. Okay, so next applications of echo. What is the meaning of applications? Okay, applications means uses. Okay, uses of echoes. That only applications. In applications of echo, first some animals are communicating with other animals using this echo. Okay, sending the sound, using the sending and receiving the sound by through that they are communicating. Some animals are communicating with other animals. Okay, so some animals locating or targeting the objects. Okay, by sending the signals and that signals reflecting in that particular object and reflecting back, falling on the object and reflecting back to them. From that, they are finding the objects. Okay, locating the objects. These are the uses for the animals. Second, it is used in the obstetric ultrasonograph. Okay, this principle, this echo principle only used in the obstetric ultrasonography. Okay, so through this ultrasonography here, using this echo, they are getting the real visual images of the embryo. Okay, the embryo and the fetus in the human uterus. Okay, so that in the mother's uterus they are taking the clear visual images. Okay, so for this here no harmful effects because of this echo. So it is a safe way, okay, to get the real images of the embryo. Next, the third case, that echo is used to determine the velocity of sounding medium. Echo is used to find out the velocity of sounding medium. These are the three uses or applications. Okay, first animals are using these echoes to communicate with others. Then they are using to locating the objects. Okay, by sending the sound, and that sound is reflecting on the falling on the objects and reflecting back. From there they are locating the objects. Like that. In the second case, it is used in this same principle, only used in the obstetric ultrasonography. Okay, so here they are taking the visual images, clear images of embryo. Okay. Next, in the last, this echo is used in the used for finding the velocity of sound in different areas. Okay. So next, measuring velocity of sound by echo method. Okay, velocity of sound by echo method. How we can measure? For that, on velocity of sound by this echo method. Okay, here we need one source of sound, one reflecting surface we need, next one stopwatch, then one measuring tape. Okay, these 4 apparatus we need. Okay, for measuring the velocity of sound. First, we have to keep the source of sound pulses, the source of sound pulses we have to keep at a place, okay. Then we have to, using the measuring tape, we have to measure the distance between the source of sound and the reflecting surface. We have to keep the reflecting surface also, okay. Then receiver, then another receiver we need. That if we are keeping the source of sound here, this is the reflecting surface, we have to measure the distance between them using the measuring tape. Next, adjacent to this source of sound, we have to keep the receiver also. Okay, so we have to keep the receiver also. Then from this source of sound, the sound pulses are falling on this reflecting surface and coming back. Okay, then the time taken by the pulses to for sending for the pulses going time and coming back time. Okay, that we have to measure, and by using the stopwatch and using that we have to find the velocity of sound. V is equal to 2d by t. Okay, 2d means the distance going time and coming the time, the distance. Okay, then t is the time taken to reach the receiver, the sound pulse. Okay, so that time. So 2d by time. That is V is equal to distance travelled by time. V is equal to distance travelled by that pulse by time taken. Okay, for like this we have to find out the some amount, number of pulses. Okay, different, like in this way different 2 or 3 times we have to take this, and we have to find out the average for this, and using that we can find out the measure the velocity of sound using this echo method. Okay, children. Next, applications of reflection of sound. Already today we have learned applications of echo. Okay, this applications of echo is very important question right there. Okay, applications of echo. Before that, the conditions necessary for hearing an echo. Okay, then now the application of reflection of sound. Okay, there are 3 applications are there. Okay, applications of reflection. Applications of reflection of sound. In these applications of reflection of sound, there are 3. First one is soundboard. Okay, this soundboard is always concave surface only. Okay, so this soundboard is a concave surface board. It is used in the hall, big auditoriums and halls to hear the sound clearly. Okay, this soundboard is kept in this soundboard is sound that speaker is kept in the focus of this soundboard. Okay, soundboard is concave surface. So in this concave surface, in the focus of this concave surface only we have to keep the speaker. So the sound will concentrate and it will hear by all the audience, okay, of that hall clearly. Okay, so because of this we are hearing the sound clearly. So audience can hear the sound by improving some quality. Okay. So for improving the quality of sound only, we are using this soundboard. Okay. Soundboard is improving the quality of sound in auditoriums and halls. Okay. So here importantly the soundboard is concave surface. The speaker is kept in the focus of this concave curved surface. Okay, children. So this is soundboard. The second one is the ear trumpet. The second one is the ear trumpet. Okay. So in this ear trumpet used by the disabled hearing. So somebody cannot hear, that a disabled people using this ear trumpet. Okay. In this ear trumpet, one end is wide, another end is narrow. Okay, so the wide end through the different sounds are going through this wide end, and it is reflecting on the tube of the walls of the tube, and reflecting through the walls of the tube and concentrated in the narrow end. Okay, and the person can hear the sound very clearly and concentrated manner with high intensity. With high intensity, the person can hear the sound. Okay, so this ear trumpet is used by the hearing aid. Okay, this is the hearing aid. This is the people who cannot hear clearly, they can use this. Okay, this ear trumpet is the hearing aid. Okay, next, third one is megaphone. Okay, this megaphone is used for a gathering of people to hear the sound clearly, for the small gathering of people. Okay, here in this megaphone also, one end is wide, another end is narrow. Okay, here in between the two ends, a tube is there. Okay, small tube. If we are talking, if the person talking in the narrow end, the sound is reflected in the walls of the tube and can hear clearly through the wider end. Okay, so the persons can hear the sound clearly, clear manner and high intensity. Okay, so because of multiple reflection, the people can hear the sound through the megaphone clearly and with high intensity. Okay, children. Next, Doppler effect. So here once more I am saying what are the applications of reflection of sound: soundboard, ear trumpet, megaphone. These three important uses are there because of the reflection of sound. Okay, so in the next, what Doppler effect? What is Doppler effect? First you see, children, yes, train is going. We are standing there and listening the sound of the whistle sound of that train. Okay, if it is going, okay, it is going away from us. The sound will reduce. The intensity of the pitch of the sound reducing if the train is going away from us. If the train is coming towards us, the sound is reducing. Towards us, the sound is increasing. Sorry, students. If we are standing at a place, the train is crossing us. If the train is going away from us, the sound is decreasing little by little. Okay, the pitch of the sound is decreasing. If the train is coming towards us, the intensity of the sound, the pitch of the sound increasing. Okay, we are hearing in increased manner. Okay, that is not as the original sound. The that if the train is moving away from us, the sound we are hearing the sound reduced manner. It is little by little reducing. It is different from the original sound of the train, whistle sound. Okay. But if the train is coming towards us, we are hearing the sound, higher sound. The pitch is higher little by little. It is increasing. Okay. That is also not different from the original sound of the train. Okay. So, because of the relative motion between the listener and the source of the sound. The source of the sound here is train. The listener is ourself only. Okay. So in that way, if both are moving or both are in relative motion to each other, the apparent frequency is different from the original frequency. Okay. So that is called Doppler effect. Okay. The original frequency is different from the apparent frequency. The apparent frequency what we are hearing while the train is passing away from us, while the train is coming towards us. Okay. So that is called as that effect. The different, that if there is no any relative motion between the observer or the listener and the source of sound, that apparent frequency is different from the original frequency. This effect is called as Doppler effect. Okay children, in this Doppler effect there are different possibilities. The relative motion due to this relative motion is having some different possibilities. Okay, you see the listener is moving away from the away or towards. Okay, away from the listener is moving towards or away from the source at rest. The source is at rest, the listener is moving away or coming towards. Now in this first case, there is the source of sound is at rest. That means the train is standing. Okay, at rest. Next, the second case, the source is moving away or towards the listener. Now the listener is at rest. In the second case, the listener is at rest. Okay. So in the third case, both the listener as well as the source, both are moving away or moving towards. Okay. So in the last case, we can find out the medium. Okay. So the medium where that moving, that the medium of this listener and the source, that is at rest. Okay. Like this, different possibilities are there for the relative motion. Sometimes the listener is at rest. The first case, the source is at rest, listener is moving. In the second case, the listener is at rest, source is moving. In the third case, both are moving. In the last case, the medium is at rest. Okay. So here, what is the definition for this Doppler effect? So, children, this is very important. We have to study that thoroughly. Okay. So, I am writing here what is Doppler effect. Whenever there is a relative motion between the source and the listener, the frequency of the sound heard by the listener is different from the original frequency. Original frequency of any emitted by the source. This is known as Doppler effect. This is the definition. How to write in your note and how to learn well. Okay. Children, once more I am reading. Whenever there is a relative motion between, now you know what is relative motion. Both are moving. Sometimes both are sometimes listener is moving, sometimes source is moving. Whenever there is a relative motion between the source and the listener, the frequency of the sound heard by the listener is different from the original frequency of the sound emitted by the source. Okay, what sound the source is emitting, that one same at the same frequency we can observe. The hearing frequency, the observers, the frequency of sound heard by the observer is different. Okay, from the original frequency of sound waves. This is known as Doppler effect. All of you understood? Now we have to find out the calculation for this. Okay, here for this Doppler effect we have the calculation. For this calculation we have to take So here for simplicity of this calculation we have to take the medium is at rest. Okay, this is the relative, the medium is at rest and the listener and the source that is in relative motion. So here we can take N is the listener, S is the source. Okay, we have to note N is the listener, S is the source. Then V L is the velocity of sound here by the listener. Okay, so S is the Vs. Velocity of sound. Okay, this is velocity of sound by the listener. This is velocity of sound by source. Okay, so here the first case, one case we are going, different possibilities are there. Here we are going to learn one case, both listener and source. Both are moving towards each other. Okay, they are both are moving. So the sound, the frequency of sound is decreasing. Okay, so that N is the frequency of sound. Okay, original sound. N dash is the apparent sound. Okay, children, N is the original sound produced by the source and N dash is the apparent frequency of sound produced here by the listener. This is frequency of sound. Okay, so N dash is equal to V plus Vn divided by V minus Vs into N. This is the formula. Okay, V is the velocity of sound in a medium. Okay, in this case the medium is at rest. Okay, so N dash is the velocity of frequency. Okay, apparent frequency. We have to find out the apparent frequency of sound. N dash is equal to V plus Vn divided by V minus Vs into N. Okay, children. Now this you all know, I think. So like this, different possibilities are there. Different possibilities. Then that listener source is at rest and listener is coming towards the source. Then listener is at source is at rest, listener is coming towards. Then listener is at rest, source is coming towards and moving away. Like this, different possibilities are there. So according to that, we have to change the formula. Okay. The next case. Suppose now we have this we have considered the medium is at rest. If we are taking the medium is in movement, what will happen? Okay, if the medium, for example, if the medium is wind, if it is moving, what will happen? The velocity of wind we want to take W. Okay, so if the wind is moving along the direction of motion of the sound, we have to take V plus W. Okay, if the wind is moving against the direction of propagation of wave, we want to take V minus W. Okay, wherever we are writing V, we have to write V plus W. If the sound, wind is or the medium is moving along with the direction of propagation of that sound. Okay, if the direction of if that wind is moving against the direction of propagation of wave, we have to subtract V minus W. Okay, so wherever we are using V, we have to add V plus W or V minus W. Unless you understood, children. So next, what are the conditions for no Doppler effect? This is important. Okay, important thing for expression for the not expression, condition for no Doppler effect. This is an important question. Okay, so what are the conditions for no Doppler effect? Okay, first condition you see, children. First, source and listener both are at rest. When the source and listener both are at rest, we cannot find out any Doppler effect. Okay, so both L, yes, both are at rest. Okay, in the second case, both are moving. Okay, so that source and listener both are moving along in same direction, but they are maintaining same distance. Okay, the distance between them constant while moving from one place to another place. Both are, one is following another one, but the distance is same. Okay, remaining same. Okay, in the third case, that in the, you see, children, both are, the source and listener both are moving in a distance, at a perpendicular distance. Both are moving normally. Okay, both are moving normally. If the source is moving in this position, then listener is going in the another position. Okay, perpendicular distance. Okay, so that is, in this case we cannot see any Doppler effect. Okay, in the fourth. Okay, in the fourth case, the source is at the center and the listener is moving along the circumference of the circle. Okay, the source is the center and the listener is moving along the circumference of the circle. In these cases, we cannot find out any Doppler effect. Okay, we cannot find out any Doppler effect. These are the conditions for no Doppler effect. Okay, children, once more I am saying, first, the listener and source both are at rest. In this case, we cannot find out any Doppler effect. Then second case, the source and listener both are following one behind another. In this case, they are maintaining equal distance between them. In that case, we cannot find out any Doppler effect. In the third case, source and listener both are moving perpendicular to each other. The last case, the source is at the center of the circle and the listener is moving along the circumference of the circle. In this case, we cannot find out any Doppler effect. This is one important question. Conditions for no Doppler effect. If you want to learn well. Okay, children. In the last, what are the applications of Doppler effect? Applications of Doppler effect. First, tracking the high-speed vehicles. Okay, how can in the one source of sound is there. Okay, the sound that source emitting electromagnetic waves. That electromagnetic waves falling on the speedy vehicles, and it is reflecting on the speedy vehicles and coming back to the receiver in the police car. Okay, so from the frequency shift of that electromagnetic wave received by this police car, they will find out the speed of that vehicle. Okay, they will find out they will track the speedy vehicles. Okay, that is the first. Then second use, tracking the satellite. Okay, satellites are emitting radio waves. Okay, so if the satellite is going away from the earth, radio waves received by the receiver in the earth and finding the frequency shift. Okay, from that frequency shift, we can find out how much distance it is going. Okay, at which distance the satellite is there, we can find out. Okay, in the third case, radar means radio detection and ranging. Okay, so in radar, it is emitting radio waves. These radio waves falling on the reflecting surface such as aeroplanes and aircraft and coming back. And from the frequency shift of that aeroplanes, that radio waves from the receiver, they will find out they will track the aeroplanes or aircrafts. The last, sonar. Okay, sonar is used in sea. Okay, that waves are sending inside the sea, and that submarines or sea animals, that waves are falling on the sound waves are falling on the sea animals or submarines and coming back. Okay, from that the sending and coming back, from that time they will find out the distance, at which distance they are. The submarines are there, like that we can find out, and they can track that. Okay, these are the uses. There are 4 uses. First is using to find out the speedy vehicles. Second one for finding the satellites. Third one, sonar, radar. Fourth one, sonar. These are the applications of this Doppler effect. Okay, children, all of you understood that, I think. So whatever you have doubt, you can ask to me. You all learned well this last question, applications of Doppler effect also very important. Before that, the conditions for no Doppler effect, that is also important. So whatever already I told questions, you have to learn well. Thank you.